Okay, hello guys. So we will continue with the introduction about the gem module in SimG. This is one of the famous modules for compositional and unconventional simulator. But in this tutorial, we will talk about compositional simulator because we will consider this simulator for CO2 sequestration process. So I can say the GEM is the Geochemical EOS of state or EOS compositional simulation. So let's move on the presentation of features related to SimG compositional simulator, which is a simulator of choice in SimG for modeling of CCS. As you can see, many of the features will be directly described during the tutorial, where we will dig into the simple model for carbon sequestration. Also, GEM provides numerical simulation tools for processes such as convective and dispersive flows, starting from the stop relative permeability hysteresis with residual gas saturation and modeling solubility of ratio ability of solubility in aqueous phase. The aqueous phase with related phenomena such as solubility increase with the increasing pressure and solubility degree with increasing temperature or salinity, as well as reduction of bright density and viscosity change a function of the amount of CO2 that gets dissolved into the water. And also the water vaporization is accounted for in our model. Each option that has been turned on by the user. And of course we will see how to do that. And this phenomena come with the possibility of the water rise or water rise out effect which has been observed in the proximity of the white bore where the water could be completely rise out from the wellbore. Okay, and also geochemistry is already included or implemented in GEM with the addition of several geochemical databases for building the mineral dissolution and the precipitation reaction in our CO2 sequestration process. And it related with ionic property of the fluid in the rock. And we will be seeing that GEM connect to a number of geochemistry databases like QC. This is one of the famous modules for geochemistry. And this module, for instance, and there are other from which GEM can find the information regarding the reaction and component. And of course, all of you guys will see how to use the database during the score. Don't worry about that. And I can say GEM is one of the powerful for compositional simulation. GEM also be run in the thermal module, so thermal effect can also consider the thermal effect. Okay, the thermal effect can consider in the model by GEM. And finally, the geomechanics or caprock integrity also implemented in the simulator. And in this specific instance, geomechanics will be used for modeling the caprock, evaluation and the rupturing. So that's all about the introduction for gem function in our simulation core. We will continue with the next slide. I will talk about the qubit equation of state. So EOS is the term of equation of state. Okay. At representing the basic assumption built into the gem simulator for compositional simulation purpose. Okay. So EOS will be used for compositional reservoir simulation in our simulation core. And the concept may result very useful in understanding the behavior of carbon dioxide. It is injected into the reservoir. Hence, we would like to go over a few details pertaining the BVT robotic activity modeling to make sure that we are on the same page regarding the fluid compositional simulation. And this is only dedicated to qubit equation of state in the particular. So, SimGem adapted this idea for CO2 sequestration modeling. And one of the concept of EOS we already bought or apply in oil and gas petroleum reservoir. But in this case, we try to borrow this knowledge for CO2 sequestration modeling. And this slide we will talk about the advanced state of EOS. Okay. So by using this equation, it is relative symbol equation for the thermodynamic property and the phase equilibrium relationship of interest. Okay. Because it is just gas or a more complex multi-component fluid, like we see in the petroleum engineering. In general, it is accurate, or more sophisticated, but less rapid form of BVT model. Okay. For oil and gas system, and its objective ultimately is to work out density, fluidity, okay, and equilibrium phase composition based on the composition of the reservoir, and also the phase composition based on the input property of the reticle pressure, reticle temperature, and the anesthetic factor or interaction coefficient. So the parameter, of course, the pressure, temperature, and condition at a time step should be considered during the simulation. Not all about the introduction about function of SimGem and advantage of EOS. We will continue to introduce some basic function of EOS for next video, and see you on guide.